Hello, my dear mechanical marvels. How are you all? What's up? Can you guys hear me? Am I audible and visible to you all? Please do let me know so that we can start our session. How is everyone? Can you guys hear me? Those who are watching me live, please respond through the comment section. This is Chandra Shekhar welcoming you all to the India's largest, the best, and your favorite live learning platform, that is BYJU'S Exam Prep. And you are watching me live through this new series for BARC and HAL examination, that is atomic series, and we are discussing the numericals, the questions from heat transfer subject, which is very simple, very highly scoring subject. Today is the second session for heat transfer, that is part 2. First of all, do let me know if I am audible and visible to everyone. नमस्कार, आदाब, शुभ संध्या, good evening, सत श्री अकाल, अस्सलाम वालेकुम, वणकम. Welcome to the session. So today we will be discussing some beautiful numericals from the topic convection mode of heat transfer, radiation and heat exchanger. Hi Rovin, good evening, welcome. How are you? What's up? So keep your pen, notebook and calculator handy, because the questions, you are supposed to solve the questions, and whenever you will be having any difficulty, you can raise your doubts through the comment section. All right. Before I start, quickly introduce myself. I am a mechanical engineering graduate from IIT Delhi, and I have also cleared engineering services examination. I have worked in sale for a couple of years, and I have also worked in a private consulting firm. From last 9+ years, I am into teaching, guiding the students who are preparing for various competitive examinations. These are my subjects which I am comfortable with. So if you have any doubt in any of the topics which are mentioned over here, you can be connected with me through the Telegram group. My Telegram group is Mechanical by Chandra Shekhar Sir. All right. And those who are new to the platform, do not forget to subscribe the channel, because once you subscribe the channel BYJU'S Exam Prep, you will be getting all the updates for our upcoming series, so that you can attend those classes which are completely free and get benefited. All right. And do not forget to be part of the session conducted by your own Abhinav Negi sir on strategy to conquer GATE 2023. Hi Manas, good evening, welcome. How are you? So shall we start? Are you all ready? Please keep your pen and paper and calculator along with you, so that you should solve the numericals. You will develop the confidence once you will do on your own. There is a question, first question on the screen from the convection mode of heat transfer. Chaliye, do solve it, everyone, and do let me know your answer through the comment section. Air at 20 degrees Celsius is flowing over a flat plate which is 200 mm wide and 500 mm long. Length is 500 millimeter and width is 200 mm. And the temperature of the fluid is 20 degrees Celsius, pre-steam temperature of air. Find the ratio of rate of heat loss from the plate when air is flowing parallel to 500 mm side with the same velocity, with the velocity 2 meters per second, pre-steam velocity, and flowing parallel to 200 mm side with the same velocity. So the question is, you need to find out the ratio of heat transfer Q1 when the air is flowing parallel to the length, and the ratio of Q1 by Q2 when the air is flowing parallel to the width. Velocity will remain same. The question is to find out Q1 by Q2. And the properties of air at 60 degrees Celsius. Why 60 degrees Celsius? Because the film temperature is, what is film temperature? Are you guys aware about the film temperature? What is the surface temperature? The plate temperature Ts is equal to 100 degrees Celsius. So the film temperature, all the properties must be used at film temperature. That is the mean of Ts and T infinity. That is 100 plus 20 by 2. That is 60 degrees Celsius is called as the film temperature. All the properties of the fluid must be used at this temperature. So the question is to find out the relation between Q and L. First of all, can you just let me know whether the flow is laminar or turbulent? How to find out whether the flow is laminar or turbulent? The first step is to check whether the flow is laminar or turbulent. Can you check it? By calculating the value of Reynolds number. Reynolds number at the trailing edge, that is U infinity into L by kinematic viscosity. What is the value of Reynolds number? Reynolds number will be U infinity is 2 meter per second. U infinity is 2 meter per second. Those who are coming now, those who are watching me live, please respond through the comment section so that the class should not become monotonous. Everyone, please keep your keyboard near to you so that you can talk to me through the comment section. The more you talk, the more you communicate, the more you share your knowledge, the more comfortable you become. My question to everyone is, what is the value of Reynolds number? Rho into U infinity into, the question is to find out, my question is to calculate the Reynolds number at x is equal to L. That is rho into U infinity into L by mu. Or we can say U infinity into L by kinematic viscosity. What is the value of Reynolds number? Free stream velocity is 2 meter per second. L is 500 mm, that is 0.5 meter. And kinematic viscosity is given. This is the kinematic viscosity, 18.97 into 10 to the power minus 6 meter square per second. So 2 into 0.5 upon 18.97 into 10 to the power minus 6. That will be the Reynolds number. So Reynolds number at the trailing edge will come out to be, how much you are getting? What is the value you are getting? बताइए. Is it 5? What is the answer? What is the value of Reynolds number? Can you do the calculation? 2 into 0.5 divided by 18.97. One divided by 18.97. It will be 5.27 into 10 to the power 4, isn't it? Because the value of Reynolds number is less than 5 into 10 to the power 5. So the flow will be laminar. And for laminar flow, we can say Nusselt number, average Nusselt number, that is H into L by Kf, thermal conductivity of the fluid, is proportional to Reynolds number to the power 1 by 2 into Prandtl number to the power 1 by 3. Do you remember this expression? For laminar flow, the Nusselt number is given by this expression. Yes, Rovin, yes, Manas, good, good, good. All other students also do let me know. From here, can you develop a relation between H and L? Reynolds number is containing L. So L to the power half, there is L again here. So do you agree? And H is inversely proportional to root L. So if it is length, then it will be 500 mm. If it will be width, then it will be 200 mm. So do you agree Q1 by Q2 is equal to under root of L2 by L1? Isn't it? And what is L2? L2 means width, B. L1 means L. So the ratio of Q1 by Q2, are you able to see whatever I am writing? Let me hide myself. So the ratio of Q1 by Q2 is equal to under root of 200 by 500. What is the answer? So under root of 200 by 500 will be the answer. That will be the ratio. Which option is correct? Quickly. The time is equally important. You should take care of the time. You should solve the question as early as possible. Is this clear? What is the ratio of Q1 by Q2? That is under root of 200 by 500. Under root of 0.4. That will be 0.63. Are you getting 0.63? Any doubt? Clear? Let us talk about the next one. Second question on the screen. Yes, Romin, very nice. Now let us move to the next one. The question was from external flow. Again, air stream at 24 degrees Celsius, T infinity. It is again external flow. Air stream at 24 degrees Celsius is flowing at 0.4 meter per second across a 100-watt bulb at 130 degrees Celsius. Surface temperature is 130 degrees Celsius. If the bulb is approximated by a 60 mm sphere, 65 mm, diameter is 65 mm. The bulb is approximated by a 65 mm diameter sphere. Calculate the percentage of power loss due to convection. So do you agree? The power loss is equal to the power is 100 watt and the loss in power is due to convection. The mode of heat transfer will be convection. The power loss will be due to convection from the sphere. Convection. And Nusselt number for sphere, Nusselt number for flow of gas over a sphere is given by this expression. Nusselt number, we can say, so first of all we need to find out the value of Reynolds number. Reynolds number is equal to rho into U infinity into D by mu, or we can say U infinity into D by kinematic viscosity. First of all, calculate the value of Reynolds number. Free stream velocity is 0.4. Free stream velocity is 0.4 into diameter of the sphere is, what is the diameter of the sphere? 65 mm, 0.065 upon kinematic viscosity of air, which is given as 2.08 into 10 to the power minus 5 meter square per second. So what is the value of Reynolds number? What is the value of Reynolds number for the next one? How much is Reynolds number? Are you getting 1250? Are you guys getting 1250? And once you get the Reynolds number, use this value of Reynolds number in this expression. So we can say Nusselt number is equal to H into D by Kf, thermal conductivity of the fluid, is equal to 0.37 into 1250. 0.37 into 1250 to the power, how much is that? 0.6. Can you find out the value of H bar here? H bar is equal to 0.37 into 1250 to the power 0.6 into thermal conductivity of the fluid. Thermal conductivity is 0.03. 0.03 upon D, diameter 0.065. What is the value of H bar? What is the value of H bar? This is average convective heat transfer coefficient. What is the value of H bar? The value of H bar should be, can you find out the value of H bar? It must be 12.32. Please correct me if I am wrong. Watt per meter square Kelvin. Are you getting 12.32? And once you get H bar, then we can find out Q convection. 12.32, yes. Then find the value of Q convection. That is H bar into area of the sphere. That is the surface area. AS into delta T. 12.32 into 4 pi r square. 0.065 by 2 square into what is the value of delta T? Delta T is equal to 130 minus 24. Find out the value of heat loss due to convection. Find the value of heat loss through convection. What is the value? Quickly do the calculations. Are you getting 17.33 watt? So the heat loss due to convection is 17.33 watt. Are you getting it? And once you get Q convection, and what was total Q? What was the power? So the ratio of power loss due to convection divided by the actual power or the total power into 100 will be the percentage loss. So 17.33 watt divided by 100 watt into 100. So it will be 17.33%. Option A. Isn't it 17.33%? Option A is the correct answer. Is this clear? If it would have been 200 watt bulb, then your answer would have been 17.33 divided by 2. If it would have been 200 watt bulb, then the answer would have been 17.33 divided by 2%. Option A is correct. Now question number 3, 4 and 5 share common data. The hot air enters with a mass flow rate of 0.05 kg per second through an uninsulated sheet metal duct of diameter. It is a circular duct whose diameter is given as 0.15 meter and the length is given as 5 meter. And the hot air is entering at, this is inlet point 1, this is exit point 2. Hot air is flowing inside, so it is the example or it is the question from internal flow. There are two types of fluid flow possible. One is external, another is internal. So it is internal flow. So TB1, mean temperature of the fluid or of air at inlet is 103 degrees Celsius. At the exit, air cools to 77. TB2 is equal to 77 degrees Celsius. The heat transfer coefficient between the duct outer surface and the ambient air. There is outside air also. That is ambient air. There is a heat loss from the duct surface and ambient air due to convection. So the convective heat transfer coefficient, this is H0. T infinity is 0 degrees Celsius. The outer fluid temperature is 0 degrees Celsius and H0 is 6 watt per meter square Kelvin. And specific heat of air at constant pressure is 1010 joule per kg Kelvin. These are the data given. Now the question number 1 starts. Calculate the heat loss. Calculate the heat loss from the duct over the length L. How much will be the heat loss? So if we apply for this control volume, this is our control volume, let us say. This is the region under observation. For this control volume, this is our control volume between inlet and outlet. If we apply the energy conservation equation, this is our control volume. If we apply energy balance equation, can we say Q in plus Q generated is equal to Q out plus Q stored? There is no heat entering into the control volume. There is no heat generated in the control volume. So Q out is equal to the heat leaving, heat loss is equal to minus Q stored. It means decrease in internal energy. So the heat loss is equal to m dot into Cp into Tb1 minus Tb2. Do you agree or not? So the heat leaving from the pipe to the ambient air is nothing but decrease in internal energy of air inside, hot air inside. So that will give you the answer. Can you solve it? And let me know the answer. Question number 3. Solve question number 3. Mass flow rate is given as 0.05. Cp is 1010 into Tb1 minus Tb2 is 103 minus 77 degrees. So the answer to the question will be, what is the value? The heat loss from the duct over the length L. So the question is from basic energy balance equation, energy conservation equation. Are you getting 1313? Option A. Are you getting option A or not? Is it option A? Everyone, please do let me know. The next part of the question, if the inside convection heat transfer coefficient at X is equal to L, it means at the outlet. At outlet, that is X is equal to L. At X is equal to L, H2, that is 0.2. H2 is equal to 11.6 watt per meter square Kelvin. Determine the heat flux at X is equal to L. Determine the heat flux. Look, if I draw the outlet, this is the outlet and this is the pipe. Pipe thickness is negligible. And here there is H0, that is H2. So the question is to find out the heat loss like this. T infinity is 0 degrees Celsius. Tb2 is given as 77 degrees Celsius. This is the outlet. So can we say, if we draw the circuit diagram, there will be two resistances in series. If we draw the circuit diagram, there will be two resistances, 1 upon H2 into A and 1 upon H0 into A. So Q double dash is equal to, and this is Tb2 minus T infinity, that is T infinity. There will be two resistances which will be in series. This is the overall thermal potential. So we can say Q double dash is equal to Tb2 minus T infinity upon 1 upon H2 plus 1 upon H0. Isn't it? That will give the heat loss or heat flux at X is equal to L. Tb2 is 77 minus 0 upon 1 upon H2 is 11.6 plus 1 upon H0 is how much? H0 is 6. That will give you the answer, watt per meter square. That is the heat flux. What will be the value? Which of the options is correct? Isn't it 304.5 watt per meter square? At outlet, 304.5 watt per meter square. Isn't it? The next part, determine the duct surface temperature at X is equal to L. Now, at x is equal to L. This is the duct. The thickness is negligible. That is why conductive resistance is negligible. But the surface temperature T has to be calculated. This is TB2. The heat is flowing like this. And we have already calculated Q dash. Q dash. That is the flux. So we can say Q dash can also be written as H2 into TB2 minus TS. Isn't it? So from here we can TS2. Let me call it as TS2. From here we can find out the value of TS2. From here we can find out the value of TS2. Q dash we have already calculated 304.5 is equal to H2 is given 11.6. TB2 is 77 minus TS2. What will be the value of TS2? Can you solve it? Duct surface temperature at x is equal to L. Yes, Omkar. Nice. Good, good. How much is the value? Is it 26.25 or TS2 will be? कुछ तो गलती कर दी आपने. Are you subtracting or adding? 11.6 multiplied by 77. 893.2 minus 304.5. What is that? What is H2? 11.6. TB2 minus TS2. What is the answer? Are you getting option A? Isn't it option A? $77 minus, yes, 77 minus TS2 is equal to 26.25. And TS2 will be equal to 50.7. Yes, option A is correct. The next question, question number 6. Call the next one. A steam pipe having an outside diameter 70 mm, surface temperature 200 degrees Celsius. There is a pipe, steam pipe, circular pipe, and the diameter, outside diameter is 70 mm, and the surface temperature Ts is equal to 200 degrees Celsius, and emissivity of the surface, pipe surface, is 0.8, passes through a room in which air and wall are at 25 degrees Celsius. It is passing through a room where the temperature of air and the wall of the room are 25 degrees Celsius. T infinity or T surrounding, we can call it as surrounding temperature is 25 degrees Celsius. If the coefficient associated with the free convection heat transfer from the surface to the air is 15 watt per meter square Kelvin, H. This is H, 15 watt per meter square Kelvin. Then what percent of heat is lost by convection of the total heat loss from the pipe? So the heat loss from the pipe will be by convection as well as radiation. The heat loss from the pipe will be due to convection as well as radiation. Because it is the ratio, the length of the pipe can be assumed as 1 meter. Let us assume length is equal to 1 meter. So can you find out Q convection? What is Q convection? From the Newton's law of cooling, that is H into surface area available for convection into Ts minus T surrounding. That will give Q convection. Put the value. First of all, find out Q convection. H is 15. Surface area is pi dl. This is pi dl. So it will be pi into d. Diameter is how much? 70 mm. 0.07 into 200 minus 25. That is Q convection. What is the value of Q convection? Are you getting 577.27 watt? Convection is 577.27. And find out Q radiation. Also find out Q radiation. Because the pipe is placed in a room. Room can be treated as a black body enclosure. So it will be epsilon into sigma into surface area into Ts to the power 4 minus T surrounding to the power 4. Yes, Omkar. What is Q radiation? It is 0.8 into As, that is pi into 0.07 into 1 into sigma. Sigma is 5.67 into 10 to the power minus 8 into Ts to the power 4 minus T surrounding. Now you need to convert in Kelvin. Ts is equal to 200 plus 273. That is equal to 473 Kelvin. And T surrounding will be equal to 25 plus 273. That is 298 Kelvin. 473, 298. 473 to the power 4 minus 298 to the power 4. That will give you Q radiation. What is Q radiation? Yes, 420.64. Is it watt or kilowatt? So Q convection is 577. Q radiation is 420. The question is to find out the percentage heat loss by convection to the total heat loss. So percentage loss by convection will be equal to 577.27 divided by total, that is 577.27 plus 420.64. Can you get me the answer? Yes, Omkar had calculated the values correctly. Now what will be the correct answer? Question number 6. For question number 6, what will be the right answer? Is this clear to everyone? If anybody is having any doubt, you can just let me know through the comment section. Yes. Are you getting question number 6 now? Are you getting 57.8% option B? Option B. Yes, Manas, option B is the correct answer. 57.8. Yes, Omkar. Correct. 57.8%. The next one, question number 7. Question number 7, again from convection. The question is very simple. A wire of 1.5 mm diameter. There is a wire. Wire means a cylinder. 1.5 mm diameter. And the length is 200 mm. Is submerged in water to boil at 100 degrees Celsius. How much electrical power must be supplied to the wire to maintain the wire surface at 130 degrees Celsius? Ts is 130 degrees Celsius and the temperature of water is 100. If the convection heat transfer coefficient. So electrical power will be equal to Q. That is H into surface area available for convection into Ts minus Tw. What is surface area? It will be pi dl. Why? Because for a wire, diameter is very, very small compared to the length. So this portion will not be considered. No need to consider the cross section of the wire, because the diameter is very small compared to the length for the wire. So Q is equal to 3275 into pi into D, that is 1.5 into 10 to the power minus 3 into 200 mm, that is 0.2, into 130 minus 100, that is 30, will give you the answer. That is the power required. That much will be the power required. What is the answer? 92.6, option A. Are you getting option A? Yes, 7th option A is correct. Good. So these were the questions from convection. Let us move to the radiation. The next topic is radiation. Let us solve a couple of questions from the radiation as well. A circular ice sink 25 meter in diameter is enclosed by a hemispherical dome which is 35 meter in diameter. The D2 is given, the figure is given, and the diameter D1 is also given. If the ice and the dome surface may be approximated as black bodies, if both are black bodies, if we draw the circuit diagram, the heat flow, by using the circuit diagram, how many resistances will be there? At 0 degree Celsius and 15 degree Celsius. So it is at 0 degree Celsius, it is 15 degree Celsius. Dome is T2 is equal to 15, T1 is equal to 0. What is the net rate of radiative heat transfer from the dome to the sink? If we draw the circuit diagram, there will be one resistance 1 upon A2 F2 to 1, isn't it? Or we can call it as 1 upon A1 F1 to 2 from the reciprocity theorem. That is called as space resistance. There will only be one resistance, that is the space resistance. So what is Q2 to 1 net? Can we say sigma into T2 to the power 4 minus T1 to the power 4 upon 1 upon A1 F1 to 2, or we can write A2 F2 to 1, that is your choice. So Q2 to 1 net is equal to A1, it is a circular ice sink. So A1 will be equal to pi by 4 D1 square, that is 25 meter, into F1 to 2, because it is an enclosure. So F1 to 1 plus F1 to 2 is equal to 1, and F1 to 1 is equal to 0 because it is a flat surface. Self-shape factor for a flat surface is 0, so F1 to 2 is equal to 1. That is why we will put 1 only into 5.67 into 10 to the power minus 8, that is sigma into T2 to the power 4. Convert it into Kelvin. 273, add 273. 288 to the power 4. Don't forget to convert them into Kelvin. Minus 273 to the power 4. That will be the net heat transfer or net radiative heat transfer between 2 and 1. What will be the answer? This is the expression you are supposed to use. Solve it and let me know your answer. Yes, B is the correct one. B is the right answer. B will be the right answer. Because it is forming an enclosure, so Q1 to 2 is equal to minus Q2 to 1. Q1 to 2 is equal to minus Q2 to 1. B is the right answer. The next question, these type of questions are important. Consider two very large parallel plates with gray surfaces. This is surface 1. This is insulated from top, and this is surface 2 which is insulated from bottom. They are very large. It means they can be treated as two surface enclosure. They are parallel plates. T1 is 1000 Kelvin and epsilon 1 is 1. T2 is 500 Kelvin. Epsilon 2 is 0.8. Determine the irradiation for the upper plate, plate 1. What is the value of G1, irradiation? Robin, because they were black bodies, na? Both are treated as black surfaces. If the ice and dome surfaces, it is mentioned here, if the ice and dome surfaces may be approximated as black bodies, for a black body, the surface resistance for a black body will be equal to 0, isn't it? That is why we did not include. There is only one resistance, which is the space resistance between 1 and 2. Clear? Provin? All clear? Now, how to calculate irradiation? Here, so many people are having doubt. How to calculate irradiation for plate 1? Look, we can say the radiation incident on 1, Q1 incident, will be equal to, can we say Q1 incident will be equal to F221 into Q2 emitted? Please do let me know. Whatever the radiation emitted by 2, the fraction of radiation reaching 1. So Q1 incident is equal to F221 into Q2 emitted. Is this clear? And Q1 incident can be written as G1 into A1. G1 into A1, that is Q1 incident, is equal to F221 into Q2 emitted. 2 is not a black body. So how much radiation is emitted? We can say epsilon 2 into A2 into sigma into T2 to the power 4. Please do let me know if I have committed some mistake. Is this clear? Now we can say the question is to find out G1. G1 is equal to, here it is A2F221 upon A1 into epsilon 2 into sigma into T2 to the power 4. And what is A2F221 upon A1? Can we write it as F122 into epsilon 2 into sigma into T2 to the power 4? And what is F122? We can say F121 plus F122 is equal to 1. F121 is equal to 0. It is enclosure theorem. This is 1 into epsilon 2, 0.8 into 5.67 into 10 to the power minus 8 into T2 to the power 4. Indirectly, they want you to calculate the emission from surface 2. Irradiation for surface 1 will be calculated from emission from surface 2. The irradiation, what is the answer? Question number 9. Is it B or A? Is it option A or B? Why you guys are writing B? Omkar, is it B or A? How did you calculate? Is it option A or B? This is how you will get G1 in watt per meter square. You should be clear with this concept. You should be clear with this concept. Isn't it? Are you getting 2835 watt per meter square or not? I am getting option A, or I have mentioned option A. Please do correct me if I have committed some mistake. The value of G1 insolation irradiation for the upper plate. G1. 2835? Yes, it should be 2835. Now the next part is, yes Manas, good. The next part is, what is the net radiation exchange between the plates per unit area of the plate? How to find out Q122 net? The formula you should always memorize. That is sigma into T1 to the power 4 minus T2 to the power 4 upon 1 minus epsilon 1 upon epsilon 1 A1 plus 1 upon A1 F122. There will be 3 resistances. 1 minus epsilon 2 upon epsilon 2 into A2. And if we want to find out Q122 by area A1, that is Q dash plus, then we can say it will be sigma into T1 to the power 4 minus T2 to the power 4 divided by it will be 1 minus epsilon 1 upon epsilon 1 plus 1 upon f1 to 2 plus a1 by a2 into 1 minus epsilon 2 upon epsilon 2. Because a1 is equal to a2 is equal to a, because they are very large parallel plates, they will get cancelled out, and f1 to 2 is equal to 1, and epsilon 1 is, what is the value of epsilon 1? Epsilon 1 is equal to 1. So if you solve these, then you are left with, this will become 0. And then q dash from 1 to 2 will be equal to epsilon 2 into sigma into t1 to the power 4 minus t2 to. That will give you the answer. So epsilon 2 is 0.8. Epsilon 2 is 0.8 into 5.67 into 10 to the power minus 8 into t1 to the power 4. What is t1? What are the values of t1 and t2? 1000 and 500. So 1000 to the power 4 minus 500 to the power 4 will give you the answer. What is the answer to this one? Question number 10. Question number 10. Are you getting option A? Question number 10, option A is correct. Heat flux per unit area. Radiation heat flux per unit area. Next couple of questions from the heat exchanger. The question is, hot oil is cooled from 80 to 50 degrees Celsius in an oil cooler which uses air as the coolant. The air temperature rises from 30 degrees Celsius to 40 degrees Celsius. TH1 is equal to 80, TH2 is equal to 50 degrees Celsius. The air temperature TC1 is equal to 30 degrees Celsius and TC2 is equal to 40 degrees Celsius. The designer uses a LMTD value of 26 degrees Celsius. The type of heat exchanger is, you assume parallel flow, and if you assume parallel flow, for parallel flow mean temperature or LMTD will be given by, this will be theta1 or delta T1 minus delta T2, delta T1 minus delta T2 upon natural log of delta T1 by delta T2. That is the formula. So delta T1 is 80 minus 30. This will give delta T1, that is 50 minus delta T2 is 10 upon natural log of 50 by 10, that is 5. What is the value you will be getting? It is around 24 degrees Celsius. If you assume it as parallel flow, you will be getting 24 degrees Celsius. The mean temperature for parallel flow or LMTD for parallel flow, that is not matching, so it cannot be parallel flow. Assume it as counter flow and calculate LMTD. Assume counter flow, then LMTD. In that case, if you assume it as counter flow, then the curve will be like this. This is TH1, this is TH2, this is TC1, this is TC2. So this is delta T1, TH1 minus TC2, that is delta T1. 80 minus 40 is 40 minus TH2 minus TC2, TH2 minus TC1, that is 50 minus 30, that is 20 upon ln of 2. If you calculate counter flow, then you will be getting 28, around 28 degrees Celsius. Isn't it? So it is neither counter flow nor parallel flow. It is neither counter flow nor parallel flow. Because the designer value is neither matching with parallel flow LMTD nor it is matching with Counterflow LMTD. Yes. So if it is neither parallel flow nor counterflow, then it cannot be double pipe. Double pipe means concentric tube type. Double pipe means concentric tube type. It can either be parallel or counter. So because if it is neither parallel nor counter, then it cannot be double pipe. So it is cross flow. So LMTD of cross flow lies between, it is less than LMTD for counterflow and it is greater than LMTD for parallel flow. So the correct answer is option D. It is cross flow heat exchanger. Yes, Karan, very nice. So that is how you can find it out. If the designer value would have matched with parallel flow heat exchanger value, then the answer would have been parallel flow as well as double pipe. It could have been MSQ. If the parallel flow is the correct answer, then double pipe will also be correct. If the counterflow is the correct answer, then double pipe will also be correct. But if because it is neither parallel nor counter, so it cannot be a double pipe heat exchanger. It is complex heat exchanger, that is cross flow. Question number 12 on your screen. In a parallel flow heat exchanger, inlet temperature on the hot and cold water are 75 and 20 respectively. The exit temperature of hot and cold water is 45 and 32. TH1 is equal to 75, TC1 is equal to 20, TH2 is equal to 45, TC2 is equal to 32. They are given. If the individual heat transfer coefficient on both sides means like this. Let me assume it is double pipe heat exchanger like this. Let me assume hot fluid is flowing inside and the cold fluid is flowing outside. The individual heat transfer coefficient on both sides, hot fluid side and cold fluid side, is 650 and 25.12. So we can say H for hot fluid is 650 watt per meter square Kelvin. Sorry, both are having same value, isn't it? On both sides are this. So HH is equal to HC is equal to 650 watt per meter square degree Celsius, and heat transfer rate Q is equal to 25.12 kilowatt. Calculate the area of the heat exchanger. Now what can be done? So Q is equal to, we can write Q is equal to U into A into delta Tm. We can find out LMTD. TC2 is 32 now. We can find out LMTD from this because it is a parallel flow. So calculate LMTD. Calculate LMTD. What is the value of LMTD? We need to find out U and LMTD. First of all, calculate LMTD for parallel flow. What is the value? It is TH1 minus TC1, 75 minus 20, 55 minus 45 minus 32, 13 upon natural log of 55 by 30. That is LMTD. Right? What is the value of delta Tm? Are you getting 29.12 degrees Celsius? No, Omkar, you have committed some mistake. Are you getting delta Tm as 29.12? First of all, calculate delta Tm for parallel flow correctly. That is 29.12 degrees Celsius. Now you need to find out U. How to find out U? First of all, calculate R equivalent. That is 1 upon HH into area plus 1 upon HC into area. That is equivalent. Because the thickness is negligible, conductive resistance will be 0. We have done because R1 is almost same as R2. Inner radius and outer radius is same. That is why conductive resistance will be 0. So we can say A into R equivalent will be 1 upon HH plus 1 upon HC. And U into A into R equivalent is equal to 1. So U is equal to 1 upon A into R equivalent. Put the value of R equivalent. So it is 1 upon 1 by HH plus 1 by HC. That will give you the different value. So it is 1 upon, what is H? H is 650. 1 by 650 plus 1 by 650. So it is 2 by 650. So 650 by 2 will be the value of U. Are you getting it? U will be 650 by 2. If you are getting the value of U correctly over all heat transfer coefficient, then you will not find any difficulty. Are you getting it? So that is why if you put the value here, then you can say Q is equal to 25.12 into 10 to the power 3 is equal to U is equal to 650 by 2 into area is unknown and 29.12 will give you the answer. What is the area? What is the area? Are you getting 2.65 or not? Option A. Please do let me know if you are getting option A or not. Option A will be the right answer. Option A will be the right answer. Is this clear? And the last question for the day. In a certain heat exchanger, both the fluids have identical mass flow rate specific heat product. So CH is equal to CC. Or we can say C minimum is either CH or CC. The hot fluid enters at 76, TH1 is equal to 76, TH2 is equal to 47. Cold fluid entering at TC1 is equal to 26, TC2 is equal to 55. The effectiveness of the heat exchanger. What is effectiveness? Q actual by Q maximum. And what is Q maximum? The effectiveness can be written as CH into TH1 minus TH2 upon C minimum into TH1 minus TC1. That is how effectiveness can be calculated. Robin Richard will tell you. Or we can write CC into TC2 minus TC1 upon C minimum into TH1 minus TC1. C minimum will get cancelled out. So this will give you the effectiveness. Can you calculate effectiveness? Current when they are same. Look, how to calculate U. Those who were part of my class, I had discussed this thing. Look, how to calculate U. U is called as overall heat transfer coefficient. And how to find out U? U can be written as delta T overall upon R equivalent. Sorry. Q can be written as, look, Q can be calculated by delta T overall upon R equivalent, or we can say U into A into delta T overall. So from here we can say U is equal to 1 upon A into R equivalent. That is how you can calculate U. And what is R equivalent? There are 3 resistances in series actually. The first resistance is 1 upon HI into A. The second resistance is ln of R2 by R1 upon 2 pi KL. The third resistance will be 1 upon H naught into A. Because AI is equal to A naught. Because R1 is equal to R2. So this resistance will be 0. So there will be 2 resistance. This will be delta T overall. So R equivalent will be equal to 1 upon HI or 1 upon A into 1 upon HI plus 1 upon H naught. And put the value here, then you will get. That is how. Manas, mostly FM and heat transfer. These 2 subjects, I am definitely taking FM and heat transfer. And sometimes I may take thermodynamics as well. But mostly fluid mechanics and heat transfer I have already taken Manas for the ongoing batch. I have already completed FM and thermodynamics. All right. So you can join us. So if you will join in the next batch, then we will again give you the content or give you the classes for FM and HT. All right. So that is all from my side. In the evening at 8 p.m. do join me at 8 p.m. today or tonight. Do join me for the numerical practice from the thermodynamics on the same platform. That is for 2023. Manas, you can be part of our free class at 8 p.m. So today's topic will be basics and first law. Some portion of first law of thermodynamics I was not able to cover in the theoretical session. So today I will cover the first law of thermodynamics theoretical portion also, as well as we will discuss the numericals. So do join me at 8 p.m. and ask your friends also. You will understand, I will make you understand the first law of thermodynamics the way you have never understood. For the steady state flow process, for the unsteady state flow process, and for a closed system. There are three situations: closed system, and then open system can have steady flow process or unsteady flow process. Karan, yes, tomorrow Dheeraj sir will be taking the class for another subject at the same time 4 p.m. BARC classes are going on, but I have completed thermodynamics and heat transfer. Now Dheeraj sir will be, and fluid mechanics also, and now Dheeraj sir will be taking the next class for BARC at 4 p.m. at the same time, and at 8 p.m. there is another series going on for Mastering GATE 2023, Mastering Concept for GATE 23. So see you everyone at 8 p.m. tonight. Thank you guys. Thank you very much. Take care. Stay safe. Yes, Robin, definitely I will share the PDF for this. Thanks a lot. Jai Hind. Take